In this video for section 7.1, we're talking about the standard deviation as a ruler. And we talked earlier in chapter 3 about z-scores, and remember that a z-score measures the number of standard deviations away from the mean a given value is. And earlier we used that to compare values. So we have this rule. It's called the 68, 95, 99.7 rule. It's also sometimes called the empirical rule. And the empirical rule works for a unimodal symmetric distribution. Remember, unimodal means that it has one peak, and symmetric means that it is the same on both sides. And if we have that type of distribution, 68% of the values will fall within one standard deviation of the mean, 95% will fall within two standard deviations, and about 99.7% will fall within three standard deviations. And we can see that in this picture below. So this pink line in the middle represents the mean, and then we can add one standard deviation, two standard deviations, and three standard deviations. We can also subtract one standard deviation, two standard deviations, and three standard deviations. And so using these percentages, like if we know 68% fall within one standard deviation, then 34% will fall between the mean and plus one standard deviation, 34% will fall within the mean minus one standard deviation. So that's just dividing that in half. And then using some subtraction and basic arithmetic, we can figure out these other percentages of each of the other areas. So we're going to do an example here. We have an Oreo factory where the mean mass of a cookie is found to be 40 grams, with a standard deviation of 2 grams. Use these values to label the x-axis of the graph below. So my mean is 40, so that goes on the middle line. And then I add the standard deviation, which is 2, to get 42. Add a second standard deviation, so add another 2, that gives me 44. And add a third standard deviation, adding another 2 gives me 46. And then to fill in the numbers to the left, I subtract the standard deviation, subtract the standard deviation again, and subtract the standard deviation again. So on the x-axis, I have the different values of, in this case, the grams of a weight of cookie. So my first question is, in what interval would you expect the central 95% of cookies to be found? So looking at my graph, 95% fall within two standard deviations of the mean. In this case, that's going to be between 36 and 44 grams. Question 3 says about what percent of cookies will weigh more than 44 grams. So looking at my graph, 44 is right here. More than 44 includes these two percentages. The area of 2.4% between 44 and 46, and there's an area of 0.1% that is 46 and greater. So if I add those two percentages together, I get the total percent of cookies that will weigh more than 44 grams. So 2.4% plus 0.1%, which equals 2.5%. Question 4 says about what percent of cookies will weigh between 36 and 40 grams. So looking at my graph, we have 36 to 40 is the area enclosed in here, and the total percentage of that area is 34% plus 13.5%. And if I add those together, that equals 47.5%. And question 5 says to describe the weight of the lightest 2.5% of cookies. So looking at my graph, the lightest 2.5% would be this area right here. And in terms of the weight, that's going to be 36 grams or lighter. When you're doing the homework problems for these, they're going to give you a graph, but they're not going to have the percentages in each section marked. So just be aware that you might want to have this graph open on your computer or have it printed out so that you can write numbers on it. That might be helpful.